Now let's see esterification. Okay. Now how does esterification work? When we talk about esterification, let's start with an example. Let's say that I have something like ethanol and ethanoic acid. Okay. Ethanol and ethanoic acid, and I want to form an ester between these two. Okay. Now the reagents I would use are concentrated sulfuric acid, okay, and I would use heat, but heat mildly. This is actually around 60 degrees Celsius. If you guys remember, हमने elimination of alkenes के लिए भी क्या use किया था? Concentrate H2SO4, elimination of alcohols, dehydration के लिए, but उसमें we used to use around 200 degrees Celsius. So that's why the word heat can mean a lot of things. It can mean 200 degrees or 60 degrees, but in this case, it's like heating mildly. Okay. Now, how does the ester form? Let's actually look at this reaction a bit more closely, right? Now, you might have learned in O levels that, you know what, the alcohol loses the H and the acid loses the OH, right? But why does that happen? Let's try to understand that as well a little bit, right? So this is my acid, right? And this is my alcohol, my acid and my alcohol. Now, what happens in this reaction is, you don't have to draw this, but what happens in this reaction is this, that जो अल्कोहल का जो ऑक्सीजन होता है ना, अल्कोहल का जो ऑक्सीजन होता है वो जाके कहाँ अटैक करते हैं? वो जाके वहाँ कहाँ अटैक करते हैं? एसिड के कार्बन को. So what happens essentially is that this CH3CH2O group substitutes for the OH group. This group on the left, it essentially ends up replacing the OH group, and what ends up combining over here? The OH is removed from the acid and the H is removed from the alcohol. So you end up making water. So this is what happens in this reaction. So if you had to draw the final structure, what would happen? This CH3 CH2O, right? This CH3 CH2O will end up bonding to the C double bond O, right? And that will be the ester that you're making, and you're also going to make water. So now what you end up making is an ester over here. This is called the ester linkage. So this linkage over here is called the ester linkage. Okay? An ester will always have this linkage present. Now over here what you have is you have this carbon COOC, right? COO, and then this oxygen is bonded to the carbon here. So this is always going to be found in an ester. Okay. Ester linkage. Now, what I also want to, now my next question over here is that if we write the structural formula for this, ester, what does it look like? We have CH3, CH2, OCO, CH3. Okay? CH3, CH2, OCO, CH3. This is the same as saying CH3, CO2, CH2, CH3. CH3, CO2, CH2, CH3. These two are the same molecules. It's just that यहाँ पर मैंने क्या लिखा हुआ है? I've written the alcohol part first, right? And the acid part second. Can everyone see that? I've written the alcohol part first, CH3, CH2, O, जो alcohol से आया था, and then I've written the acid वाला part. So then what does the ester linkage show up as? The ester linkage shows up as OCO. Okay, so OCO जब आपको नजर आएगा, then you have alcohol followed by acid. On the other hand, if I write the acid part first, so if I write it the other way around, instead of saying CH3 CH2 OCO CH3, I can say CH3 COO CH2 CH3, or CH3 CO2 CH2 CH3. So in this case, it's reversed, right? Whenever I see whenever I see this, CH3CO2, so whenever I see this guy over here, whenever I see a CO2 or a COO in the ester linkage, that means what's written first? Acid and then alcohol. Okay, so these two are the same ester. It's just that अगर मैं identify करना चाह रहा हूँ alcohol कौन सी थी और acid कौन सी थी, I have to look at the structural formula. If you see CO2 written, you should know that the acid part was on the left and the alcohol part is on the right. And if you see OCO written, you should know that if you see OCO, then you should know that the alcohol is written on the left and the acid part is on the right. Okay, so these two are exactly the same ester. And then obviously your other product over here is water. Now this reaction is in equilibrium. In other words, in the presence of acid, you can actually go backwards to form back the acid and the alcohol under the same conditions. Okay, so it's in dynamic equilibrium as well, this reaction. Okay, now how do we name this ester? When you want to name an ester, you take the alcohol part. Okay, this group is called ethyl, and then you take this part over here, which is called ethanoate. Right? So what's the name of this ester? Ethyl ethanoate. Okay, ethyl ethanoate. You guys remember ethanoate kya hota tha? CH3COO, right? And ethyl is just CH3CH2. So that's where the name comes from. But technically this oxygen is from the alcohol. But in the naming convention, we essentially include it as this. This is ethanoate and this is ethyl. So over here, what we had was we had a 2-carbon alcohol. That's why it's ethyl, and we had a 2-carbon acid, so it is ethanoate. This was a 2-carbon alcohol, okay, and this was a 2-carbon acid, right? So if I asked you what were your initial reactants, you would have ethanol and ethanoic acid. Ethanol, 2-carbon acid, and 2-carbon alcohol, ethanol, and then 2-carbon acid. So this is the naming convention for esters. And because, as I said before, sometimes you'll see this reaction referred to as a nucleophilic substitution reaction because this group is substituting for the OH, but it's not technically a nucleophilic substitution in the sense that you've learnt it. And this is also known as you'll also see this referred to as a condensation reaction. Condensation, because two molecules are combining to make a larger molecule, and H2O is being lost. Okay, in condensation reactions, a smaller molecule is lost when two molecules combine. Okay. All right, so let's look at another example. All right, so the next example that we have here is the next example. Let's say that I have over here, okay, and this is reacting with, so these are my two reactants, and what I have over here is I'm using over here what? Concentrated sulfuric acid, and I'm reacting it around 60 degrees, so I'm heating it mildly. Okay, now can you guys tell me the structural formula of the product and the name of the product? So what do you have here? You have a 1-carbon alcohol, that's methanol and propanoic acid, right? Now first of all, the alcohol will lose its O and the acid will lose the OH, and what will happen is that this guy over here, the CH3 CH2CO, right? Acid lost its OH, and then what will happen? The OCH3 from the alcohol will combine, right? So what do you have? This is your compound. You can also say CH3, CH2, CO2, CH3, right? So we can clearly see here, and I'll show this again, right? What do we have? We have a CH3OH, and we have the OH from the acid, right? We have this. What's happening here? The alcohol is losing its H and the acid is losing its OH, right? So what do you have? You have CH3, CH2CO, that's from the acid, and then you have the OCH3 from the alcohol. So sometimes you'll see COO, but it can also be written as CO2, okay? And what if I wrote it the other way around? What if I wanted to write the acid part? What if I wanted to write the alcohol part first? It will be CH3O, CO, and then CH2, CH3. So if I wrote this down this way, you can also say CH3, OCO, CH2, CH3. So what do we have here? We have a 3-carbon acid, 1-carbon alcohol. 3-carbon acid, 1-carbon alcohol. 1-carbon alcohol, and then this CO is from the 3-carbon acid. Okay? So the name for this compound again, यहाँ पर OCO देखोगे तो the acid group is on the right. CO2 देखोगे या COO, acid group is on the left. And this C in the middle is part of the acid group. Okay? So what do we have here? We have a 3-carbon acid and a 1-carbon alcohol. So it will be methyl propanoate. And obviously water is also being produced. So water is also being produced. So again, these are all identical. These are just different ways of writing the structural formula for the same molecule. Let's say I had a molecule like this. Let's say that I had a molecule like this, and I had an OH group here and a carboxyl group here. And what I did was, I ended up heating this with, let's say that I heated this with what? Concentrated sulfuric acid. Okay. Now what type of a reaction can take place here? I'm saying I just have one molecule of this. What can happen here? Can I have esterification take place here? What if the OH from the same molecule went and bonded to this carbon here? Would that be esterification? A carboxyl group be present or alcohol group be present? So this is called self-esterification. A same molecule can essentially close up to make an ester. Now what's happening is, इसी molecule के alcohol group, इसी molecule के साथ, उसी molecule के acid group के साथ क्या बना रही है? Ester linkage बना रही है. Can everyone see that? Let's think of it this way. Let's say that I have, let's number these carbons. Carbon 1, 2, 3, 4, 5, and 6. So I have a 6-carbon, right? So let's say that over here I have over here this ester linkage, right? पहले क्या था? यहाँ OH था, और अब क्या बन गई यहाँ पर? Ester linkage बन गई. अब carbon 1, you have 1, this is carbon number 1, right? Then you have carbon number 2, right? Then you have carbon number 3, then you have carbon number 4, carbon 5, and then carbon 6. Can everyone see that over here? What happened? What I did over here was that the carbon with the OH, that was carbon number 6, right, ended up bonding, that ended up making an ester linkage with carbon number 1, which was the carbon with the acid group. Essentially what's happened is, ये molecule है, right, this molecule is essentially, this oxygen is essentially gone and bonded over there. And what's been released in the process? Water is being released in the process. So this is also an esterification reaction. This is an example of self-esterification. Essentially, the same molecule is making an ester with itself, essentially, right? The OH group from the same molecule, the alcohol from one molecule from the same molecule is making the ester linkage with the acid group. Now, for the next example, let's say that we have something like this, right? 2-hydroxypropanoic acid. 2-hydroxypropanoic acid. पहले हमारे पास क्या था? This was 6-hydroxy 6-hydroxyhexanoic acid, right? 6 carbon acid. Now we have 2-hydroxypropanoic acid. We have 3 carbon acid with an OH on the second carbon. Now let's say that again, what I do is I use concentrated H2SO4, okay, and I heat it. And again, this is the only thing that I have present in the solution. Now obviously over here, this OH can't easily attack this carbon directly. Why can't it? Because यहाँ पर तो it had space to fold, right? 6 carbon ring बना सकते हो, 2 carbon ring बन ही नहीं सकती. You can't really make a ring here. It's not possible, right? So what do you have then? Well, let's think of it in a different way. Let's say that I have this molecule here, okay? And I'll draw it in a bit of a different way. If you guys want, you can draw it like that as well. You have this carboxyl group, and then carbon number 2 pe what do you have? OH and methyl. Carbon number 1 is the acid group, and carbon number 2 is the OH and the methyl group. You see that? Basically, that's the first carbon, right? 1, 2, 3 carbon chain. So carbon number 2 pe hydroxy, or carbon number 1 pe acid. So 1, 2, 3, right? And now let's take the same molecule and draw it on the other side, like this. We have again the same. We have the same 3 carbon chain, but now I've just shown the acid group नीचे की तरफ and the alcohol ऊपर की तरफ. Now what kind of a linkage can these two molecules form आपस में? Can I form an ester linkage here? Right? If I have the carboxylic acid ka OH and this alcohol ka H, I can form an ester linkage between this alcohol and this acid group, right? And I can also form an ester linkage between this alcohol and this acid group over here. Can everyone see that? So essentially what's happening is two molecules of this are combining. Two molecules of this are combining to form what? This kind of a compound. Okay, I've essentially just redrawn these two over here in this form. Can everyone see these two molecules here? They combine, you form an ester linkage over here, right, between this carbon and this oxygen atom here. So this is one ester linkage that you're forming, and the other ester linkage that you're forming is over here. So this is a cyclic diester. Okay, the first one was a cyclic ester. Now you have a cyclic ester with two ester linkages, and you obviously are releasing how many moles of H2O this time? 2 moles of H2O. So this is another example of how here this एक ही single molecule अपने आप के साथ ester बना रही है, यहाँ पर two identical molecules are combining to make an ester, a diester, okay, a cyclic ester. So these are some examples of how you can form cyclic esters as well. This over here is an example of a cyclic ester, and this is an example of a cyclic diester because you have two ester linkages here. Let's look at some more examples of different types of esters that we can get, right? One type of ester that we can get is, for example, let's say that I had something like this. Ethane dioic acid esterifying with, let's say, ethanol. Okay, and over here again, let's say that I have concentrated H2SO4. That's my catalyst, right? And I heat around 60 degrees Celsius. So heat mildly. Now how many ester linkages will form here? How many ethanol molecules will react with this guy? 2, right? For every 1 molecule of this, I'm going to need 2 ethanols. The reason why is, again remember this guys, कि जो ethanol का जो alcohol का oxygen होता है, it bonds to the C double bond O of the acid. So what you can have over here is that the alcohol C double bond, the alcohol's oxygen, right, this guy will end up bonding to this carbon, and it can also bond to this carbon. Okay, and remember this OCH2CH3, this entire thing will essentially replace the OH group. Okay, that's why the acid loses the OH. So your ester would look like this. You'd have CH3, CH2, right? O, right? This comes from the alcohol. This will bond to the C double bond O, C double bond O. Again, this is the acid part. Okay, and then you have, what do you have here? O, CH2, CH3. So again, I'll highlight this. The CH3, CH2O from the alcohol, okay? The oxygen atom from the alcohol will bond to the C double bond O from the acid. Okay, so this is an example of another diester over here. Okay, this is the acid, this is the dioic acid that we had, and this is the alcohol that we had. And if you had to write down the structural formula for this, this is what it would look like. If you write down the structural formula for this, you have CH3, CH2, then you have what? OCO, right? CH3, CH2, OCO, and then CO2, CH2, CH3. And in this case, if you write it from the right to the left, you get the exact same thing. Notice? Because आप लेफ्ट से लिखें या राइट से लिखें, राइट से लिखें या लेफ्ट से लिखें, आपका क्या आएगा? पहले कौन सी ग्रुप आएगी हमेशा? अल्कोहल वाली. तो पहले आपका CH3, CH2 आएगा. अल्कोहल ग्रुप जब पहले लेफ्ट पे आती है तो क्या एस्टर लिंकेज shows up as OCO. So you have the single bond O first, and then you have the acid group, the CO2. So over here you can clearly see, whenever you see OCO, right, you can clearly see that this part is your dioic acid, right? Because you see an OCO here, because you see an OCO to begin with, right? That means you had an alcohol at this on one end, and then you see a CO2 and then a CH2, CH3. That means the alcohol over here is coming after the ester linkage. So you can clearly see that there's an alcohol group here, there's an alcohol group over here, and an alcohol group over here. Okay. Now on the other hand, we can also have the exact opposite, right? We can also have something like this. What if I had ethane 1,2-diol? Okay. I'll write down the names for this. This is ethane dioic acid, and this is ethane 1,2-diol. And now let's say that this guy polymerizes with ethanoic acid. Polymerizes ethanoic acid, or not polymerizes, kya keh raha hu, esterifies. Okay, so let's say that it esterifies with, not polymerizes again, esterifies, makes an ester with ethanoic acid. Now again, how many ester linkages will you form? 2. But in this case, you have a diol. So what you see here is that, again, the oxygen from the alcohol bonds to the carbon from the acid. Just remember, this way is the easiest way to remember, rather than saying acid loses the OH, alcohol loses the H. The easiest way to remember is oxygen from the alcohol bonds to carbon from the acid. C double bond O. Okay. So what do we have here? We have, now on this left hand side, this oxygen will first be bonded to this carbon. So on the left, we're going to start with a CH3, C double bond O. Then we have an O, CH2, CH2, and then we have the oxygen, this oxygen over here bonding to this CO, CH3. So this would be C double bond O, CH3. And if you had to write the structural formula for this, you'd get CH3, CO2, CH2, CH2, OCO, CH3. Now over here we can clearly see that अगर आपको OCO दिख रहा है, इसका मतलब right hand side पे क्या है? Acid है. और अगर आपको CO2 दिख रहा है, इसका मतलब left hand side पे क्या है? Acid है. So over here it's very obvious that the two acid groups are at the ends. The two acid groups over here are at the ends. Okay, and we can clearly see that the alcohol group here is in the middle. The alcohol group kahan se aata hai? It comes after the CO2 and before the OCO. So you have two alcohol groups here in the middle, and here Because you saw an OCO, that means you had an alcohol on the left and an alcohol. We saw CO2 here, so that means you had an alcohol on the right. So here, evidently, you had two alcohol groups at the ends and a dioic acid, and here you had two acid groups at the end and you had a diol. And you should be able to identify the initial reactants just by looking at the structural formula here. Is that clear? And over here, obviously, two molecules of ethanoic acid, and obviously also there's two water molecules being released in both cases because you're making two ester linkages, right? It's a condensation reaction. And again, obviously, you should know this, but you're obviously using concentrated H2SO4 and you're using heat. Now, and this is also a reversible reaction because you can use an acid and heat to hydrolyze an ester as well. Okay, that's why we draw this as a reversible reaction, like that, right? Now, so now we're going to look at specifically that backward reaction, which is called hydrolysis of esters. Now, the reason we use concentrated H2SO4 over here is to ensure that the forward reaction is more favored. अगर पानी ज़्यादा होता, तो फिर the backward reaction would be favored because then you'd have hydrolysis. So for hydrolysis, we usually use, rather than concentrated acid, we use dilute acid. Okay. So now we're going to look at hydrolysis of esters. Okay. So when we talk about hydrolysis of esters, let's say that I have something like this. And for those of you that take bio, you should be able to identify this for me, right? And let's say that I have this massive 15 carbon chain, okay? You don't need to worry about what it is. Okay. So I have this kind of a compound here. Now what type of compound is this? Does anyone know? This is a triglyceride, right? Right? You have ester linkages between. Now, again, for those of you that don't know what triglyceride is, okay, this is just an example. They don't expect you to know if you're not in bio, okay? And now let's say that what I do is first I take dilute acid, okay? You can use HCl and you heat, okay, under reflux. I just put that in parentheses, okay? And now what bond do you break in hydrolysis of esters? The ester linkage, specifically the bond that you break. Anytime you're hydrolyzing an ester, the bond that you break is this bond. It is a C single bond O between the carbonyl carbon and the oxygen. It's always a C single bond O. So you're going to break this bond over here. Okay. So when you break this bond here, right, what do you have? These are all going to become OH groups, and then this C double bond O will become remember, these are part of the acid groups over here. So what do we end up making? We end up making this compound here. Okay, just an example of, and you also end up making, remember, this O becomes OH again, it becomes the alcohol group again, and then we also have 3 moles of what being formed, right? C15, H31, CO2, H, right? Because you have carboxylic, this becomes a carboxylic acid again, right? And you have 3 identical of these, so for every 1 mole of this, you're going to produce 3 moles of these. Yes, yes. So this is glycerol and fatty acids. Okay, this is just an example of how this understanding is used in biology. Okay. Now, what if on the other hand, I used NaOH aqueous? Okay, so this was an example of acidic hydrolysis. Okay, now I can also have alkaline hydrolysis. Alkaline hydrolysis में I use NaOH aqueous and again I'm going to heat. Okay. And it's the same idea. The ester linkage will break. The ester linkage will break, and I will make an alcohol. Okay, but now instead of making the acid, I will make what? अगर carboxylic acid बन रही है hydrolysis से, अगर carboxylic acid बन रही है लेकिन alkaline solution में, तो carboxylic acid क्या बन जाएगी? The carboxylic acid will become the salt of the carboxylic acid, right? It will lose its proton, remember, because it will basically get neutralized by NaOH because it's an alkaline solution. So you'll make CO2 minus and Na plus over here. Alright, so looking at the next example here, let's say that I had an ester like this. Okay, so we have two examples here. First, let's look at the first one and then look at the second one. So you look at the first example here, you have this ester. You have CH3OCO, CH2CH3. Now over here, if you see OCO, what group is on the left? OCO means the alcohol, the single bond O is on the left, so that means that it must have been an alcohol group. And then you see a CO, CH2, CH3, so that must have been the acid, right? So when you hydrolyze this guy, right, you break this bond here. I'll draw it out also. When you see CH3OCO, this is what it is, right? OCO, CH2, CH3. So you're going to break this bond here. You're going to break this bond over here. And when you break that bond, you produce methanol and you produce propanoic acid. This was methyl propanoate. Now remember, this ester can be written the other way around as well. You can write CH3CH2, CO2, CH3. In this case, we have a 3-carbon acid and again a 1-carbon alcohol. It's the same thing. These two are the exact same compound. It's just they've been written in reverse orientations over here. Okay. On the other hand, this is acidic hydrolysis. On the other hand, if I had alkaline conditions, then I would make the alcohol again, but I'd make a anion of the acid. अगर NaOH होता तो Na plus आ जाता है यहाँ पर. But basically in solution आपका क्या होगा? anion बनेगा acid का, because H plus जो है वो OH minus के साथ neutralize हो जाएगा. Okay. So this is acidic and alkaline hydrolysis. Similar thing here. We saw this example of a cyclic ester earlier, right, where you had self-esterification. Now you can reform the initial compound. The idea here is this, that you had a 6-carbon compound, right? Remember the carbon with the acid, right? This is where the ester linkage was being made. It was being made between this oxygen from the alcohol and this C double bond O from the acid. So when I hydrolyze it, I'm going to break that bond, and when I have a 6-carbon ring here, and when I open it up, I get a 6-carbon chain. Carbon number 1 pe I have the OH, the acid group, and carbon number 6 pe I have the alcohol group. So I get a 6-carbon chain again with an acid and alcohol on the ends. Okay. And again, if I use alkaline conditions, I'll make the anion of the acid.